Hi all, welcome to lecture 6 of module 4. In the last lectures we have seen protocols for converting physical address to logical address and also from logical address to physical address, that is RARP, ARP protocols. Okay. So today we are going to see a routing protocol, which is actually a routing protocol for routing within an autonomous system. Okay, so that protocol is called open short path first. Okay, so before going into this routing protocol, we have to learn what is an autonomous system and what is the structure of internet, okay, and what is the purpose of this OSPF. Okay, അപ്പോൾ നമ്മൾ OSPF-ലേക്ക് കടക്കുന്നതിന് മുമ്പായിട്ട് എന്താണ് ഇൻ്റർനെറ്റ്, OSPF എന്തിനാണ് ഉപയോഗിക്കുന്നത് എന്നുള്ളത് നമ്മൾ ആദ്യം കാണാം. So internet is made up of large number of independent networks or autonomous systems. Okay, so look at this. This is a example for an internet. Okay, so it consists of different types of a large number of autonomous systems. So this is an autonomous system. This is another autonomous systems, and large number of autonomous. There will be many autonomous systems. So all these autonomous systems are connected, and they form the internet. Okay, so what do you mean by autonomous system? Autonomous system is a group of network or a group of router that is coming under the single administration. Okay, that is it is being controlled under a single network administrator. That is called an autonomous system. Okay, for example, an institute will be having an autonomous network system. Okay, an ISP, internet service provider, will be having an autonomous system. Okay, so all these autonomous systems are connected, and these are connected through when all these are getting connected, they form internet. Okay, so this open short path first, which is a protocol for routing within an autonomous system. ഒരു ഓട്ടോണമസ് സിസ്റ്റത്തിനകത്ത് പാക്കറ്റ്സുകൾ അങ്ങോട്ടും ഇങ്ങോട്ടും റൂട്ട് ചെയ്യാനാണ് എന്ത് ചെയ്യുന്നത്, വി ആർ യൂസിങ് ദിസ് OSPF. ഓക്കെ, ക്ലിയർ. ഇനി so such a protocol which is also called intra-domain routing. ഓക്കെ, ഒരു ഓട്ടോണമസ് സിസ്റ്റത്തിനകത്ത് റൂട്ടിംഗ് ചെയ്യുന്നതിന് നമ്മൾ വിളിക്കുന്ന പേരാണ് ഇൻട്രാ-ഡൊമൈൻ. Okay, the routing that is being done within an autonomous system, which is called intra-domain. Okay, for that we are having a protocol, and that protocol is called open short path first. Okay, let us go into the details. Internet is made up of large number of independent networks or autonomous system. Okay, so this internet is made up of a large number of autonomous systems. Inside of its own network, an organization can use its own algorithm for internal routing or intra-domain routing. Okay, so each of these autonomous system can use their own algorithm for internal routing. This autonomous system will be using a particular algorithm. This will be using another algorithm. Okay, so all these autonomous systems can use their own routing. Okay, so that is called intra-domain routing. That is called, such a routing is called intra-domain routing. Okay, so the protocol used for this intra-domain routing is also called interior gateway protocol. Okay, അപ്പോൾ ഈ ഇൻട്രാ-ഡൊമൈൻ റൂട്ടിങ്ങിന് ഉപയോഗിക്കുന്ന പ്രോട്ടോക്കോൾ നമ്മൾ കോമൺലി പറയുന്നത് ഇൻറ്റീരിയർ ഗേറ്റ്വേ പ്രോട്ടോക്കോൾ. Okay, so what is called interior gateway protocol? The protocol used for this intra-domain routing. Okay, what do you mean by intra-domain? The routing performed within an autonomous system. Okay, ഒരു ഓട്ടോണമസ് സിസ്റ്റത്തിനകത്ത് പെർഫോം ചെയ്യുന്ന റൂട്ടിങ്ങിനെ നമ്മൾ റൂട്ടിംഗ് പ്രോട്ടോക്കോളിനെ നമ്മൾ വിളിക്കുന്ന പേരാണ് ഇൻറ്റീരിയർ ഗേറ്റ്വേ protocol. Okay, so one such protocol is called open short path first. OSPF is an intra-domain routing protocol based on link state routing. Okay, അപ്പോൾ ഇതിൽ ഉപയോഗിക്കുന്ന ടെക്നോളജി ഏതാണ്? ലിങ്ക് സ്റ്റേറ്റ് റൂട്ടിംഗ് ടെക്നോളജിയാണ് ഉപയോഗിക്കുന്നത്. ഓക്കെ, അപ്പോൾ ലിങ്ക് സ്റ്റേറ്റ് റൂട്ടിംഗ് എന്ന് പറയുമ്പോഴത്തേക്കും നമ്മൾ മെട്രിക്സ് എടുത്തിട്ട് ഹോപ്പ് കൗണ്ട് എടുക്കും, അല്ലേ? അതാണ് ലിങ്ക് സ്റ്റേറ്റ് റൂട്ടിംഗ്. വി ഹാവ് ഓൾറെഡി ഡിസ്കസ് ദ link state routing protocol in the previous module. Okay, so this OSPF works on the basis of link state routing. This OSPF is a protocol for intra-domain routing or interior gateway. It is an interior gateway protocol. Okay, it is used for intra-domain routing. It based on the principle of linked state routing. Okay, this is the introduction to OSPF. Clear? So from the figure itself it is clear. So for this interior gate intra-domain routing, we are using the protocols like RIP, OSPF. It is given here. RIP, OSPF, EIG, RP. Okay, so we have already learned RIP. Now we are going to see OSPF. Okay, for inter-domain. So what is this? What is this called? Routing two autonomous systems, or routing between two autonomous systems is called inter-domain routing. ഓക്കെ, രണ്ട് ഓട്ടോണമസ് സിസ്റ്റങ്ങൾ തമ്മിൽ റൂട്ട് ചെയ്യുന്നതിനാണ് നമ്മൾ ഇൻ്റർ ഡൊമൈൻ റൂട്ടിംഗ് എന്ന് പറയുന്നത്. ഓക്കെ, അത് നമ്മൾ നെക്സ്റ്റ് ഇതിൽ പഠിക്കും. ഓക്കെ, so that will be seen in our next lecture. So such protocol that we are going to see is called BGP, border gateway protocol, BGP. Okay, clear? So intra-domain protocol, OSPF is an intra-domain protocol, and BGP, border gateway protocol, is a inter-domain protocol, inter-domain routing protocol. Clear? Now let us go into the details of OSPF. So OSPF is actually an autonomous systems into different area. So let us look into the figure. So this is an autonomous system. Okay, this is a full autonomous system. So this autonomous system is being divided into different area. So this is one area, this is another area. Okay, so the main task of this OSPF is that they divide an autonomous system into different area. This is a single autonomous system. Okay, don't confuse with different multiple autonomous systems. This is a single autonomous system. It is being divided into different area. This is area 1 and this is area 2. Okay, so what does this area contains? This area contains collection of networks and hosts. See, this is collection of networks and hosts. Okay, this is also containing collection of networks and hosts. Okay, then all these networks in this area is being connected. Okay, ഇതെല്ലാം connected ആണ്. All these are connected. These networks are connected. This is also connected. Okay, now there is a special type of router available at the border of each area. Okay, so this is the border of this area 1. This is the border of this area 2. Okay, at each border of the area we are having a router called area border router. Okay, so this is the area border router of this area 1, and this is the area border router of this area 2. So what is this purpose of this area border router? It summarizes the information about the area and send it to some other areas. Okay, അപ്പോൾ ഇതിന് ഈ ഏരിയനെ കുറിച്ചുള്ള കാര്യങ്ങൾ ഇത് സമ്മറൈസ് ചെയ്യും. Okay, it summarizes the information about this area 1. So this router summarizes the area summarizes the details about this area 2. Okay, and send it to other areas. അപ്പോൾ നമുക്ക് ഇപ്പോൾ area 2 wants the information about this area 1. Actually this area border router will be giving this information to area 2. If area 1 wants the details of area 2, so this area border router of this area 2 will be giving information to area 1. Okay, so that is called area border router. It is actually present in the border of the particular area. Okay, now there is a special type of area called backbone. Look at here, this is a area called area 0 called backbone. The main purpose of this backbone is that it is used to connect all the areas, all the areas in this autonomous system is be connected. Okay, this area, this is an autonomous system, this is the area, and this area is being connected, and this area is being connected. So such all these areas will be connected through this area 0 called backbone. Okay, so this is the purpose of a backbone area, and this backbone area will be having special routers called a backbone router. See, backbone router. There are many such backbone routers available in this backbone. Okay, so this backbone or area 0 is used to connect all these different areas in an autonomous system, and this area will be containing routers called what? This area 0 or backbone is having routers called backbone router. Okay, clear? So this backbone router is actually numbered as area 0. Rest of the areas are numbered from area 1, 2, etc. up to n. Okay, this is how OSPF works. Okay, so OSPF, it is actually dividing an autonomous systems into different area. Okay, and at each border, at each border there will be having a the border of each area will be having a area border router. This area border router will be giving the information about this area to the other areas. Okay, all these areas are connected through what? A backbone area. This backbone area will be having a backbone router which transfers information between each other. Okay, clear? This is the general structure of a OSPF. Clear? So areas. So the same thing we have just explained is actually mentioned here as well. To handle routing efficiently and in timely manner, OSPF divides an autonomous systems into area. Okay, autonomous systems are divided into different areas. An area is a collection of networks. Okay, so area is a collection of networks, hosts and routers, all contained within an autonomous system. Okay, ഇതെല്ലാം ഒരു ഓട്ടോണമസ് സിസ്റ്റത്തിനകത്ത് വരുന്ന നെറ്റ്വർക്ക്, ഹോസ്റ്റ്, റൗട്ടേഴ്സ് എല്ലാം ആണ്. They are all connected. An autonomous system can be divided into different areas. All the network inside an area must be connected. Okay, all those network in this particular area are what? They are connected. Okay, at the border of an area, a special router called area border router summarizes the information about the area and send it to other areas. Okay, we are having a special router called area border router. Okay, it is present at the border of each area. Then among the areas inside the autonomous system is a special area called backbone area. There is a special area called backbone area. This is area 0. Okay, backbone. All the areas inside the autonomous system must be connected to this backbone. Okay, അപ്പോൾ എല്ലാ areasum connect ചെയ്തിരിക്കുന്നത് is using connected through this area 0 backbone. Okay. Next, the router inside the backbone are called backbone router. Okay, ഒരു ഏരിയക്കകത്ത് ഏരിയ 0ക്കകത്ത് വരുന്ന എന്താണ് റൗട്ടറിനെ വിളിക്കുന്ന പേരാണ് backbone router. Okay, the router that is present inside an area 0 or backbone is called backbone router. Okay, each area has an area identification. The area identification of the backbone is 0. Okay, ഓരോ ഏരിയയ്ക്കും each area will be having area identification. This is area 1, this is area 2, but backbone will be having the identification area 0. Okay, now clear? So this is what this is the statement we have to explain in 10 and under areas. Okay, so OSPF is being divided into different areas and you have to explain these terms. Okay, next, metric. So how this routing is performed? Okay, for that we have to assign a value between each router. Okay, that is called metric. So that metric can be based on the cost or the delay or the throughput or anything we can have. Okay, so we have already learned about the hop count. Okay, the number of hops to reach from source to destination. Okay, so there we have taken the hop count. Similarly, here also we are having a metric, and the metric can be based on any parameter. The OSPF protocol allows the administrator to assign a cost, okay, called the metric to each route. Okay, ഓരോ അഡ്മിനിസ്ട്രേറ്റർ എന്ത് ചെയ്യുന്നു? They will assign a cost between each router or between each network. Okay, based on that cost we will route the information. Okay, the metric can be based on, so how this metric is assigned? The metric can be based on the type of service. That is, it can be we can assign the metric as a minimum delay or a maximum throughput, etc. Okay, clear? Maximum throughput means the maximum output. The router can have multiple routing tables. Each router will be having multiple routing tables. Okay, all these things we have already detailed in the previous sessions. Okay, so router will be having multiple routing tables. Okay, so this is an example of a metric. So here this is the original network autonomous system, and this is the graphical representation. Okay, so here we are having LAN routers. This is a LAN router. Okay, so between each LAN and router, between each node we are having a host. Okay, the administrator have assigned host. Okay, based on this cost only they will assign. Based on this cost only we will be calculating the total time or the total cost for reaching from source to destination. Okay, suppose this LAN want to reach to this R3. Okay, so what will be the cost? So 1 plus 5, 6. Okay, suppose this LAN want to reach this to this LAN 2, LAN 1 to LAN 2. So what will be the cost? So from LAN 1 will be reaching here. Okay, then 1 plus 4, 5, and then 1, that is 6. Okay, clear? So similarly this is the cost. So this is the cost that is being assigned by the administrator for between each node or between each router. Okay, clear? Next, the type of link that is available in the OSPF. Okay, in an autonomous system there can be different types of connections or different types of links. So these are the different types of links. First one is point to point, transient, stub, and virtual. Okay, so what is point to point? This is point to point. So point to point link means it connects two routers without any host or without any other devices in between them. So this point to point is just for connecting two routers. Okay, so a point to point link connects two routers without other host or router in between. Okay, അപ്പോൾ രണ്ട് റൗട്ടേഴ്സ് തമ്മിൽ കണക്ട് ചെയ്യാനാണ് ഈ പോയിന്റ് ടു പോയിന്റ് വരുന്നത്. Okay, clear? So that is called point to point connection. Next is transient link. The transient link is a network with several routers attached. Look at this figure. So this is a transient link. Here there are different routers attached to this link. Okay, ഈ ലിങ്കിനകത്ത് we are having routers A, B, C, D, and E. Okay, so the data can enter at any router and go out through any router. Suppose the data will be entering through A and going out through E. Suppose it will be entering through B and going out through C. Okay, so that is called a transient link. Transient link is nothing but it is many routers are interconnected through a link. Okay, that is called a transient link. Next is stub link. So stub link is a network that is connected only to one router. Okay, so there will be only one router available in that network. Okay, so data will be entering through this router, okay, and reaching this Ethernet. Okay, then if a data want to leave out, it will be leaving only through this router. Okay, so stub link means there is only a single router connected to a particular network. Clear? A stub link is a network that is connected to only one router. The data packets enter the network through the single router and leave the network through the same router. It can enter through the same router and leave also through the same router. That is called a stub link. Okay, so next is a graphical representation for the autonomous system. So this is an autonomous system. Okay, so this autonomous system will be having different networks. This is networks. This line is called a network. Okay, so we are having network 1, network 2, network 3, network 4, network 5, and this is also a network. This is a point to point network. Okay, so network between through two routers. Okay, okay, this is a point to point network. So totally we are having 7 networks, and how many routers? 1 2 3 4 5 6 6 routers. Okay, so this representation can be represent this can be this autonomous system can be represented graphically like this. Okay, so the square boxes represent routers. The square boxes represent routers, and this oval shape represent the networks. Okay, clear? So network 2, network 1, network 3, 5, 4. Okay, clear? Then see here, this is this is the router. This is router C, router A, router B, router D, router E. Okay, and router F. Okay, similarly also we can assign the cost in between these routes. Okay, so in OSPF, an autonomous system will be graphically represented in this manner. Okay, so let us see the theory. An autonomous system can be graphically represented like this. The figure shows a small autonomous system with 7 networks and 6 routers. 2 of the networks are point to point. Okay, so here we are having 7 networks. Okay, 7 networks, 1 2 3 4 5 6 7. Okay, 7 networks. So 2 of the networks are point to point network. Okay, so these are point to point network. We use symbols such as N1 and N2 for transient and step network. One thing is that here this N2, this network N2 is a step network. Why step network? Because only is connected only through a single router. So this is called a step network. What about this N1? N1 is a transient network. Why? Because in N1 there are multiple routers are connected. Okay, similarly N3 there are multiple routers are connected. Now N4 is a step network. Okay, step network means only a single router is connected. N5 is a step network. Okay, clear? So N2 is a step network, N1 is a transient network, N3 is a transient network, then N4 is a step, N5 is a step. Okay, now look at we will look into the theory. AS can be represented as represented graphically. Figure shows a small autonomous system. Okay, AS means autonomous system with 7 networks. We are having 7 networks: 1, 2, 3, 4, 5, 6, 7. Okay, 7 networks. There are 2 of them are point to point networks. So these are point to point network. Okay. Then we use symbols such as N1 and N2 for transient and step networks. Okay, we use the symbols N1 and N2 for what N1 and N2 oval symbols are represented. They are called transient and step network. Now use square nodes for the router and the ovals for the network. Okay, so here the square nodes for router, square for router, and oval for network. Okay, oval for network. Clear? Okay, so this is the graphical representation that is given in the OSPF. Okay, so next, so this is the concept about the OSPF, that is the routing within an autonomous systems. Okay, for that they are dividing into different areas, and each area they will be having different criteria, and a metric is given for each node. Based on that metric, they are finding the best route. Okay, and although also all those things are happening here. Okay, thank you.